Hello everyone, thank you very much for joining me today. This is a video about intrinsically safe radio apparatus as well as other electrical test apparatus that's used in explosive atmospheres such as mines, chemical industries, mills where there's high levels of dust and thus an explosion can occur, and in the explosives industry such as in demolition blasting caps, mining, open cast mining, things like that. And today I want to talk about intrinsic safety, what it means, how important it is to safety and obviously critical human safety, as well as the applications and the safety aspects surrounding it. Radio equipment such as this handheld, for example, you'll often see where they're certified in intrinsic safety for intrinsic safe apparatus. Labels on the back that have a marking identical to this, which is the cooking pot logo here with EX written in it. That means EX, that it's intrinsically safe, basically. That's the marking. And then we have different standards such as Vapour here. We have other standards around the world such as Factory Mutual in America. We have Senelec. Obviously this is Vapour. We have different ATEX standard, that's another one, and then we have markings applicable to the type of safety standard that a piece of radio equipment or electrical test apparatus will have. So for example, EEX means it's intrinsically safe. Then we have IB. Now I'll show you the codes in a moment. That means it's intrinsically safety. To an EN standard, a European Senelec standard. 2C, that basically tells us about the gas codes and the types of atmospheres this radio equipment or electrical apparatus is certified to work in, and T4 is the temperature codes, and basically the kind of classification that this equipment can operate in. Now, if you're using radio equipment in mines, for example, such as handheld radio equipment and what have you, there was many years ago a manufacturer in the UK called Pi and Philips Telecom, and they made a radio like this that worked in mines in the coal industry and throughout the world, you know, diamond mines and copper mines and any subterranean mining and tunnelling, for example, where you're going to get explosive gases like methane and other gases, which, you know, natural gas, which can cause huge explosions and kill everybody in the mine. So they made a radio that you couldn't get the battery off, because anything that can cause a spark, that can strike a spark, such as removing the battery and reconnecting the battery, and indeed there have been many instances throughout the world of serious explosions that have been caused and many lives lost through such stupidity as trying to connect and disconnect a battery off a piece of equipment that's not intrinsically safe. Things like this, for example, the metal belt clip on the back here, the types of alloys that are employed in manufacturing these, if these are struck up against a rock or you know, a rock face within a mine, they can induce a spark, a bit like striking a flint, and that's enough to cause a massive explosion and bury everybody alive. Now the thing is, a company called Pi Philips Telecom in Cambridge in England used to make a radio called the EX PF85, which is an intrinsically safe radio, and it had to have a special key that got inserted here in order for you to disconnect the battery on and off. And it was the only manufacturer, I believe, in the world at the time that had that kind of safety feature. Now, as part of intrinsically safe apparatus, a lot of these radios were reduced in transmit power, so you could get models that were 4 or 5 watts, and then you had the intrinsically safe version that did about 900 milliwatts off the antenna. And the reason for that is that simply the amount of energy or coronal discharge around the antenna, plus as well the fact that you could use it near blasting caps where RF currents can be induced into cabling or wires that go to detonators in mining, for example, like open cast mining where they're blowing out big seams. The last thing you want is to cause a false explosion by transmitting on the radio and then inducing enough RF current in nearby wires leading to blasting caps to cause an explosion. So the RF power is reduced on a lot of the intrinsically safe radios, and also indeed they had to carry the IS labelling. There wasn't allowed any belt clips or anything that was not approved, including the microphones that went in the top. They all had to be intrinsically safe approved as well. And obviously all intrinsically safe equipment has to carry the correct labelling. Now that doesn't mean that, like this piece of equipment here with that labelling, that you could use it in any environment that was dangerous. They had to be certified and classified for use in that particular area of use. And obviously only a stupid person, and believe me there are plenty in the world, that would take a charger, a mains charger for such an instrument, into a hazardous zone. That could be a radio charger that the radio connects into, or it could be a mains charger for this instrument. And naturally, by connecting anything in a hazardous zone where there are chemical vapours, gases and other explosive dust atmospheres, would cause a massive explosion if that were to occur. So there are different zones in which intrinsically safe equipment can be used, and they have to be adhered to very strictly, otherwise you risk a major disaster. Likewise, a lot of equipment as well in this particular classification has a number of countable faults which can occur within it. So not only is the equipment just designed to be an instrument as you see here in a radio, but also that they are encapsulated a lot within the circuit boards. They have current limiting devices and specialist circuits which prevent overcurrent situations during a fault condition. Indeed, some pieces of equipment like this can have as many as 2 countable faults that can occur in a hazardous zone without it causing either sufficient temperature of a faulty component to cause a source of ignition, or indeed spark or cause an explosion by allowing gas to ignite. So there are many safety features built into instruments such as this and radio equipment, and it's very important that if a part is replaced or substituted, that it's only the correct part for that item or board, and that it must be an intrinsically safe certified piece of componentry. It can't be something that's equivalent, to maintain its intrinsically safe integrity. And so bearing in mind that, of course, if a fault occurred in this radio, for example, it shorted the battery out, the last thing you want is a load of smoke caused through heat energy that's released through a transistor that's burning out, or resistor, because that temperature can ignite a gas. Some gases have very low ignition thresholds and dusts, and obviously they need to be designed, these pieces of equipment, so those kind of faults can occur without causing a source of ignition. So we can often get equipments like this that are certified to have 2 countable faults happen within them while they're in a hazardous zone, without risk of causing danger to the operator and the people that are working in that harsh environment, that dangerous environment. So if we look at the coding again on this particular instrument here, is EXIB2CT4, and we have a cooking pot logo again, which you'll see on any equipment. It can also just be EX on its own, 8X, FM, whatever, there are different standards. So I'll show you a standard here, which is the gas codes, and I'll put this link in the description as well for anybody who's interested in intrinsically safe radio apparatus. So again, we've got the EX logo here, which quantifies that it's intrinsically safe, and obviously then we have, in this case, we have IB after that. So if we have a look down at IB, we have different classifications. So we've got EXD, E, IA, IB, IC. So it says that it's intrinsic safety, and then we have the European standard as well, the Senelec European standard, which equates to that spec. So then we follow that by 2C. So if we have a look up here at 2C, and these then detail the kind of gases which these can work in. So 2C is hydrogen and acetylene, and then we've got T1 and T2. This says that it's T4 as well, so it can work up to this classification. And then we have temperature 135 degrees to 200 degrees C, and that's classes of gases and vapours according to the ignition temperature. So that's basically what that equates to. And we have different zones as well of operation. So this is zone 0, for example, and we have again a simplified explanation here. So zone 0 is within the actual tanker, for example. In this case, zone 1 is between the tanker and, say, a petrol or a filling thing. And there are different zones in all these different standards, zone 0, 1, 2, etc. And we can use these in different capacities. So that's just a little rundown of intrinsically safe equipment. And obviously this was extremely important when you're working in mining, any kind of mining or subterranean environment. It's extremely important that you make sure that, you know, they're used in accordance with the correct zones that they're certified to be used in. Petrochemicals, offshore gas and oil rigs, all these pieces of radio equipment and things have all got to be certified by intrinsically safe practices when they're being repaired, that only designated parts and things from the original manufacturer are used, and that obviously an amount of training and education needs to be brought to the users into the capacity which they can be used in. As I said earlier, only an idiot would bring a mains charger into a hazardous zone to then charge an instrument or a radio, and then would cause an explosion by inserting the radio in the charger. Just because the radio is certified intrinsically safe doesn't mean the accessory that goes with it, such as a remote speaker microphone, the battery or the charger, is intrinsically safe as well. Indeed, the Motorola GP900 intrinsically safe radio has a specialist feature in the battery, whereas if a non-intrinsically safe battery is connected, then the radio simply will not transmit. And that's obviously for good reason, because the current limiting technology is in the battery rather than in the radio, so that they've made sure that, you know, you can't use the battery while it's, you know, in that on a non-intrinsically safe battery on an intrinsically safe radio. The other thing as well is that nowadays manufacturers allow batteries to be removed from the radio without insertion of a special key or a special adapter to prevent unauthorised disconnection and connection. My own view on that, and view of many, is that you'll be an idiot to do that, to change a battery in a hazardous zone anyway. But you are allowed to do it, obviously. In this, you know, you can disconnect the battery anywhere you like. But the thing is that they tend to make the radios now so that the quiescent current, which is connected and disconnected when the battery is connected and reconnected, is so low that it wouldn't induce a spark on the contacts. But I certainly wouldn't rely on that, and I would never ever recommend changing a battery or an accessory on an intrinsically safe piece of equipment while it's in a hazardous zone. Always remove yourself from the hazardous area to affect any changes of battery or radio, microphones or accessories. And be very careful as well. You know, there's a lot of alloy labels, asset labels that get attached to radio equipment and test instruments for assetting, and people don't realise that some alloys are more prone to creating